All right, let's dive into the deep end of the physics pool, where electromagnetism and gravity are having a pool party. You see, these two forces are like the power couple of the universe, and they've got some serious connections. First up, we've got Maxwell's equations, 4 mathematical gems that describe how electric and magnetic fields behave. Imagine you're a detective, and these equations are your clues to solving the mystery of how charges and magnets interact. They tell you how electric fields spread out from charges, how magnetic fields loop around currents, and how changing fields create their counterparts. It's like a cosmic dance, but not the cliché kind. Now let's switch gears to general relativity, Einstein's brainchild. Picture space-time as a trampoline, and mass and energy as bowling balls. The balls warp the trampoline, and that's how gravity works. Things roll toward the balls because of the curves they create. So gravity isn't a force, it's just things following the curves of space-time. Mind-blowing, right? Speaking of mind-blowing, let's talk gauge theory. Electromagnetism is a gauge theory, meaning it's all about keeping things symmetric even when we change our perspective. It's like a chameleon that changes color to match its surroundings, but its true nature remains the same. Gravity, on the other hand, is playing hard to get. Physicists are still trying to figure out if it can be a gauge theory too. It's like a cosmic game of will they, won't they? Enter Kaluza-Klein theory, the matchmaker trying to unite electromagnetism and gravity. The trick? Extra dimensions. Imagine our universe is a sheet of paper, and there's a tiny rolled-up dimension, like a hidden straw. Electromagnetism and gravity are just different aspects of the same thing in this higher dimensional space. It's like discovering your favorite pizza and ice cream are both part of the grand cuisine of the multiverse. But wait, there's more. Quantum gravity is the quest to reconcile quantum mechanics with gravity. It's like trying to get a cat and a dog to be best friends. Tricky, but not impossible. String theory says particles are tiny vibrating strings, and loop quantum gravity talks about the fabric of space-time being woven from loops. It's a theoretical fashion show, and we're still waiting to see who'll be the top model. Finally, let's talk black holes and Hawking radiation. Black holes are like cosmic vacuum cleaners, sucking up everything around them. But Hawking said, hold up, black holes aren't greedy, they can also give back. They emit radiation and can eventually evaporate. But this leads to the information paradox. What happens to the information about stuff that falls in? Is it lost forever, or does it get recycled? It's like a cosmic episode of Hoarders, and we're still figuring out the plot twist.